Hey, Calc BC. Today we're going to be learning lesson 6.3, which is called P series test. In College Board's version of our course description, this is again, as with this whole unit, it will be in Unit 10, Infinite Sequences and Series. This is lesson 5 from College Board, Harmonic Series and P series. Harmonic series is a specific type of P series that we're going to be covering, along with just the general P series test today. If we go look down here at the specifics, we have, in addition to geometric series, common series of numbers include the harmonic series, the alternating harmonic series, and the P series. All right, the alternating harmonic series is something that we're going to cover in a later lesson in this unit, but today we will look at harmonic series and P series. You'll know exactly what that means in just a second. So let's switch over to the notes. All right, so here are our notes for 6.3 P series test. The series of the form summation from 1 to infinity of 1 over n to the p is called a P series. Now we've already used n to represent the number term that we are on in our sum. As you can see here, we're filling in for n, so it's going to be 1 over 1 to the p plus 1 over 2 to the p plus 1 over 3 to the p, etc. The p is a different number that will be filled in our summation notation, right? So if you take a look down here, you can see, for example, in letter A, we have 1 over the cube root of n. When we get to this question, the first thing we're going to do is rewrite this denominator so that it's in an exponent. So it'll be 1 over n to the 1/3. And then the p would be the 1/3, right? So you'll see that when we get there, the p is always a certain number. The n stays as n, right? Because all of our sums have some sort of n that tells us what to fill in when we get to that term. It'll make more sense when we get down to the bottom if that didn't click, but no worries. For p equals 1, this is a special kind of P series called the harmonic series. So you can see if it's 1 over n, p is 1, so it's 1 over n to the first power, which you don't really need to write. And that's going to equal 1 plus 1/2 plus 1/3, etc. We've looked at this sum before when we were talking about the improper integrals, but I didn't give it a name. It's called the harmonic series, and it diverges. I showed you the visual of how if you keep adding these fractions visually as an area to any sized box, they're always going to overflow the box. And we're not going to get too much into the details of like proving that this is true, but here's the specifics for the P series test. If you have a P series, it converges if P is greater than 1. It diverges if P is between 0 and 1, and it diverges if P equals 1. Okay? So if you think back to our last lesson, we talked about the nth term test. All of these different cases, technically the terms, so the sequence of terms, the terms themselves might still be approaching 0. But now we have some cases where even though these terms are getting smaller and smaller, closer to 0, they still might not converge. So that's why we can't use the nth term test to prove convergence. So if we go back and look at our chart again of all the tests, remember that nth term test can't be used for convergence. We talked about the geometric series last time. So now we're looking at P series. All of the rules are right here in this row. You can even see when P is 1, the series is called the harmonic series. On this chart, they combined our second and third properties of the tests into one to show that it will diverge if 0 is less than P is less than or equal to 1, which we have written in 2 different ways here. But anyway, let's try this. So in letter A, I already told you we're going to rewrite this as 1 over n to the 1/3. And as hopefully you can see now, comparing that with this, the P is 1/3, right? So we have what we call a P series with P equals 1/3. And when P is 1/3, which case is this? It's between 0 and 1, so it diverges. So P 0 is less than P is less than 1. Therefore, we could say by P series test, the series diverges. We really want to get into the habit of writing which test we're using to prove convergence or divergence. Let's look at letter B. Sum from 1 to infinity of 1 over n to the 5/4. This, once again, is a P series. This time we don't even have to manipulate it. And this P is greater than 1. So we could write the P is greater than 1. Therefore, by the P series test, the series converges. And when we did geometric series, we knew what the sum was, right? We said it converged to a specific sum. With P series, we don't know what the sum is. It's actually more common with these tests that we're not going to know how to find the sum. We're just going to be able to say that we know it does converge. It doesn't approach infinity. So that's something that we're going to have to just get used to. So that sometimes all we can do is write converges. We don't have the actual sum. If it's geometric series, we definitely know the sum. But let's take a look at letter C. Okay, so now we just have a bunch of terms written out. So we have to find the pattern: 1 plus 1/4 plus 1/9 plus 1 over 16 plus 1 over 25. And to me, it looks like that we could rewrite this as 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, etc. So if we were going to write this in summation notation, it equals sum from n equals 1 to infinity of 1 over n squared. Okay, and that is technically a P series with P greater than 1, right? Because P is 2 right there. So we could say, therefore, by P series test, the series converges. All right, last one. This, I think we can see, hopefully, that we could rewrite this as a summation from n equals 1 to infinity of 1 over n times the square root of n. Right, for the second term, it's 2 square root 2, then 3 square root 3, then 4 square root 4, so it's n square root n. But that's not really going to help us. It is a P series in disguise, so we have to rewrite it once. N to the first times n to the 1/2 would be 1 plus 1/2 as the new exponent, which is n to the 3/2, which now looks exactly like a P series, and P is greater than 1. So we would write, therefore, by the P series test, the series converges. All right, so hopefully that's pretty straightforward. You might have to manipulate whatever you're given so that it looks like the right format, and then you just kind of take a look at the P and decide whether your final answer converges or diverges. Okay, so that is it. Good luck with the worksheet, and let me know if you have any questions. Have a great day. Thanks.